Good day, everybody. How are you all? Today we are going to talk about hypothesis test for proportion. We will use the calculator. Fourteen percent of men said they used exercise to reduce stress. From a random survey of 100 men, it was found that 10 used exercise to reduce stress. Does the sample provide enough evidence that 14% of the population used or 14% men in the population used exercise to reduce stress? Okay, so this is a hypothesis test. My educated guess is solution 80. Null hypothesis is P is equal to 0.14. And what is my alternate? Since we have not been told to test whether it is increased from 0.14 or decreased from 0.14, we'll use the not equal to 0.4. That means null hypothesis, which is the status quo, is that the population proportion zero 0.14. This 0.14 is my 0.14 is my hypothesized population proportion. Hypothesized population proportion is equal to P0, where P0 is the hypothesized population proportion. And alternate hypothesis which is hypothesis, which is the test hypothesis. Population proportion different is not equal to 0.14. So my hypothesized population proportion is 0.14. My null hypothesis is the population proportion equal to the hypothesized population proportion, which is 0.14. And my alternate hypothesis, which is also the test hypothesis, is the population proportion is not equal to 0.14. So we will look at the evidence from the sample that we have collected. In the sample, X is equal to 10, also called number of successes. Out of N equal to 100 sample size. Use exercise to reduce stress. Reduce stress. Okay, so let me move this a little bit up. So sample proportion P hat, read as P hat, is X over N, number of successes divided by sample size. Here success are the men who use exercise to reduce stress. So P hat is X over N is equal to 10 over 100 is equal to 0.1. We will have to determine how far P hat is 0.1 is away from the hypothesized population proportion P0, which is 0.14, in terms of the standard deviation of the sampling distribution. Of the sampling distribution, standard deviation of the sampling distribution of P hat. Distribution of P hat. So we'll have to determine how far P hat, which is 0.1, is away from the hypothesized population proportion P0, which is 0.1, in terms of the standard deviation of the sampling distribution of P hat. That means find a standardized test statistic. Standardized test statistic okay, it's called standardized because it is divided by the standard deviation. Deviation of the sampling distribution of P hat, which is sample proportion. Sample distribution of P hat. Okay. Here we have to remember that we will calculate a z-score for the P hat that from our sample. If you remember, z is given by x minus mu divided by sigma over, Let me correct that. So x minus mu divided by standard deviation. Okay, this is the definition of z. Definition of z score or standard normal variable. So we are taking the difference of x from the population mean and dividing by the population standard deviation of the distribution of x. Along the same lines, when we calculate z-score for p hat, we use the formula z is equal to p hat minus p0 divided by square root of p0 times 1 minus p0 over n. Here, if we assume the null hypothesis to be true, then the mean of the sampling distribution of p hat is mu p hat is equal to p0, and the standard deviation of the sampling distribution of p hat is sigma p hat is equal to square root of p0 times 1 minus p0 over n. Oh, wait a minute. Do not just leave. I'll give you a hint at the end of the video. So please do not quit right away. Okay. So this is the long way of calculating the test statistic. So after we, let me move this up. After we calculate the test statistic, we determine what is the probability of getting a test statistic, of obtaining a test statistic which is z as extreme as what we have obtained. Okay. If then this probability is called p value. We compare this p-value with alpha, which is level of significance. Level of significance alpha is the maximum probability of making a type 1 error. Now, type 1 error. Question is, what is type 1 error? Type 1 error is made when we reject H0, even though it is true. Though it is true. It is true. Which indicates that we made a wrong decision. Indicates that we made a wrong decision. Okay, so if the p-value is much smaller, than alpha, a level of significance, then the probability of obtaining such an extreme value of test statistic is very small. So if H0 is true. Okay. Hence, we reject H0. Reject H0 if p-value is less than alpha. Oh, wait a minute, don't leave. I have some more interesting thing and I have an important hint for you at the end of this video. Okay, so don't quit right away. Okay, so let's do this test now using TI-84 calculator. Okay, use TI-84 calculator. Again, to remind you, H0 P is equal to 0.14. Hypothesized value of population proportion is 0.14, and the alternate hypothesis is P not equal to 0.14. From sample data, X, which is number of success, is 10, and sample size is 100. Alpha value we can assume and alpha is equal to 0.05. That is the maximum risk of rejecting H0 when it is true. Okay, So the question is, how will you use TI-84? Wait a minute, don't leave, huh? I'm giving you a hint at the end of this. So please don't leave right away. So in TI-84 calculator, press Start button. Then highlight means move the cursor, the black rectangle, to test on the top row. Then you will scroll down to one prop Z test. Okay. So Start button, then highlight test on the top row, then scroll down to one prop Z test, which is number 5. Okay, and hit enter. And hit enter. Then you have been asked to enter some sample statistic. Okay. So P0 is 0.14, X is 10, N is 100, and the fourth line is your alternate. Remember, this is the alternate in the fourth line. Proportion is not equal to P0. Put your cursor on the first option, not equal to P0, because I've already told the calculator that P0 is 0.14. And then you put your cursor on calculate and hit enter. So let's see what you get in the next screen, what information you get on the next screen. You get the first line is one prop Z test. Okay. And the first line says prop not equal to 0.14. Remember, this is your HA. And the test statistic Z, this is your test statistic, is minus 1.153, you might say. And let's put it minus 1.153. And the next line is the p-value, p, and that is given as 0.249. So what does all this mean? Z is equal to minus 1.14 means the sample p hat is equal to x over n is equal to 0 is equal to 10 over 100 is 0.1 is 1.15 times standard deviation of p hat below the hypothesized value of p, which is p0 equal to 0.14. Why it is below? Why? Because z is negative. Next, if I move this up a little bit, You also see the p-value is 0.29. P-value is 0.249 is the probability of getting a text statistic as extreme as minus 1.15. This probability p-value is higher than level of significance alpha. Level of significance alpha 0.45. So what does it all mean? It means there is a strong probability. There is a strong probability the sample proportion p hat can be 0.1, assuming 80 is true. And decision: do not reject 80. Do reject 80. Conclusion: at alpha 0.05, there is not enough evidence to support HA. Which states P not equal to 0.14. Do not quit right now. I'm going to give you the hint. The hint is the smaller the value of alpha, the smaller the value p-value actually, the smaller the p-value, the stronger is the evidence against the null hypothesis. What does it mean? So here, our p-value came out as 0.249, which is high compared to alpha level of significance of 0.05. If we had obtained, on the other hand, a p-value of 0.01 and compared it to the level of significance alpha of 0.05, that means smaller the value of p, the stronger is the evidence against 80. Hence, in that case, we would have rejected the null hypothesis. But in this case, the p-value is pretty high, 0.249, compared to level of significance alpha 0.05. Therefore, we do not reject the null hypothesis. That is the decision. I'll stop here today. If you have any question, comment, write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up and please share this video with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll be back next time with another math problem, another solution. Thanks for watching. Take care. Have a nice day. See you next time.